In this video, I will be discussing about the introductory concepts in motion. Motion, as you all know, is ever prevalent in this universe. Most of the objects we see every day are found to exhibit motion, whether it be the birds, the flies, the vehicles on the roads, or even the clock in your room. Motion, as we can come to infer from all this, is a change in position of an object. Motion involves a change in position of an object with respect to time. There are many types of motion. In this figure, it is showing a biker. The bike is going in a straight line through a road. This biker is exhibiting translatory motion as all the particles of the body is going in the same direction, and all the particles of this body are having the change, same positional change. Then another type of motion is oscillatory motion, in which the body keeps on fluctuating between two fixed points in space. An example of this is a buoy on a swing, as shown in the figure. Here the swing is oscillating between 2 points in fixed positions in space. Then the third kind of motion is rotational motion, in which a body rotates around an axis. Examples include Earth, as it rotates around its own axis. In this figure, it is a Ferris wheel is shown. It is also exhibiting rotational motion. Even the wheels of any vehicle also exhibits rotational motion. Then another type of motion is random motion. Random motion means the motion which is theoretically predictable but practically unpredictable. That is, it is hard to ascertain the way a body moves. In that case, that kind of motion is called random motion. Now we can see the definition of motion in a much more clear motion definition. Motion is a change in position of an object over time. As already stated, the position of an object over time, if it changes, then the body's object is said to be in motion. In this figure, it is seen that a body is at A. Now after a time T, it goes to position C. So this body is said to be in motion. After this C, if the body moves to B, now the position of this body is 4 meters from A or 2 meters from C. So the position of a body can be ascertained by giving a reference point, the direction of the body from the reference point. In case of C, it is minus 2 meters from C, implying that it is to the left of C, while in the case of A, it is plus 4 meters from A. since it is to the right. We can also attribute positive sign to left side and negative sign to left if we want. Okay then. In this case, the body has traveled a total distance of 8 meters. That is from A to C, 4 plus 2, that is 6 meter. Then from C to B, 2 meter, that is 8 meter. But the displacement of the body is only 4 meter. What we can observe is that in the case of displacement, direction of travel is also taken into account. Displacement is a vector quantity while distance is a scalar quantity. A scalar quantity in physics is a quantity having only magnitude. As examples include distance, speed, temperature. As opposed to scalar quantity, a vector quantity possesses both magnitude as well as direction, as we have seen in the case of displacement. Examples of vector quantities in physics include displacement, force, velocity, acceleration, etc. Now we can see what you mean by uniform motion and non-uniform motion. A body is said to be in uniform motion if it travels equal distances in equal intervals of time. That means if the body is traveling equal distances in an equal interval of time, that is, for example, it travels 2 kilometers in 2 seconds, it will keep on doing that, then it is said to be in uniform motion. That is, for a body traveling in uniform motion, the speed will be constant. While in the case of a non-uniform motion, it will be traveling unequal distances in equal intervals of time. Both kinds of this motion is shown by this distance time graph. Distance time graph is a graph with distance along the y-axis and time along the x-axis. As it is shown, in case of uniform motion, distance is directly proportional to time. Hence, it is a straight line passing through the origin. While in the case of non-uniform motion, it is a curve. A body which is subject to acceleration is usually going in non-uniform motion. Now we can see the definitions of distance and displacement. What is distance? Distance, as we have already seen, is a scalar quantity. It refers to how much ground an object has covered during its motion, as already shown in the earlier example. While displacement, which is a vector quantity, and it refers to how far out of place an object is with the object's overall change in position, or it is the shortest distance between the initial position and the final position of an object. Now speed. Speed is also a scalar quantity. It is distance traveled per unit time. It is how fast an object is moving. It is the magnitude of the velocity vector. Speed can be found out using the formula total distance traveled by total time taken. Now velocity. Velocity is defined as a vector measurement of the rate and direction of motion, or on simpler terms, the rate and direction of the change in the position of an object. And as already mentioned, its magnitude scalar magnitude of the velocity vector is speed of motion. Velocity can be found out using the formula. Average velocity can be found out using this formula, that is initial velocity plus final velocity by 2. Similar to this formula where average speed is equal to total distance traveled by total time taken. In the case of velocity, it is total displacement by total time taken. Now acceleration. Acceleration is the rate of change of velocity of an object with respect to time. That is, if the velocity changes with respect to time, the body is said to be accelerated. For example, if a body is dropped from a very high building, its speed, it is accelerated by 9.8 meters per second square approximately, which is the acceleration due to gravity as it falls towards the ground. Acceleration can be found out using the formula change in velocity divided by time taken. That is initial final velocity minus initial velocity divided by time. These are the basic introductory concepts regarding motion. And this acceleration, displacement, distance, speed, velocity are all discussed with respect to rectilinear motion or linear motion. And this is the end of the video. Thank you.